G'day guys, in this video we're going to show you just how accurate the PL3 really is. So to test just how accurate the PL3 is, we are going to measure this calibrated ball bar behind me. So this ball bar has an exact known length and we know exactly what the sphere diameters are, and it's measured on a sub-micron accurate CMM machine. And we have a certificate that we get renewed each year to ensure that our artifact is accurate and that when we do tests, our devices meet the specifications. So now jumping into Peel OS Pro, we're going to now 3D scan the calibrated ball bar. So we're going to click on Start a New Scan. Next, we're going to calibrate the scanner. So it's always good when you're doing a test to calibrate your system, or even before doing a job. So click on Calibrate. I'm just going to do the calibration on the floor. Okay, the calibration is now optimal. I'm next going to check my resolution, and we're going to scan the ball bar at 1mm resolution. And for the shutter speed, I'm going to use 2 milliseconds. So now I can scan the positioning targets on the table. Once we've captured the targets, we can stop the target acquisition, and under the optimization mode, I'm just going to ensure that the optimized volumetric accuracy is ticked. And this just ensures that all the targets are relative to one another and ready to go. Next, we can press Start Scan. And then just press play on the back of the scanner. Okay, so I'm happy with the data that we have. There should be enough to generate a sphere. So next we're going to stop the scan and finalize the scan data. But before I finalize, I'm just going to create a clipping plane, because we just don't need to send that data into our measurement software. Okay, we can then right click and export the mesh. So once we've hit the export button, we can then give our mesh a name and then hit save. And with any accuracy test, to do it correctly, you want to scan the part more than once. So we're going to scan it 5 times to test the repeatability accuracy of the scanner. So to save time, we went ahead and scanned the ball bar 4 additional times. And we just now need to export each of the scans that we did. So we're going to export scan number 2. And then just borrow that part of the text. Export number 3. Export scan number 4. And then lastly, number 5. Once that's completed, we can get out of PLOS Pro and launch Creaform OS. So I'm using Creaform's inspection software just to measure the ball bars, because we can set up a template with the exact sphere diameters and the distance between the spheres as a template. So we're just going to go File and Open the inspection program. So I'm just going to select add more parts, because I want to measure up to 5 parts. Then I can click on measure all, And I can import all of the meshes at once if I want to, so that they're just sitting in the background ready to be assigned to each of the parts. Once they're loaded, you then just select your first part, and I can then select measure, and instantly I'm getting a little bit of feedback on each of the spheres that I'm measuring, and I can accept that. I can then move on to part number 2, and then I can select measure all, choose my next part to measure, and then just measure each of the spheres again. And what I've done is set up a snapshot so that we can see basically the measurements of each of the ball bars. So if I jump back into navigation, we'll turn on part number 1, and the sphere diameter is 3 micron. The other sphere, number 2, diameter is 17 micron, and the volumetric accuracy is 16 micron, which is really impressive considering that the volumetric accuracy of the PL3 is 0.1 of a mil. We've far surpassed that. And the local accuracy is up to 50 microns, and it's well below that as well. So much higher accuracy than what we claim on our spec sheets. If we go to part 2, similar again, very good accuracy. So what we're going to do now is just put all of these values into an Excel sheet and look at the differences. To populate our Excel file, what we need to do is export our report to an Excel file type. So we can click on the report preview, and you can see that we've got sphere 1, sphere 2, and the distance, and we've got that for each of the different parts in the same file. So we then go to the export button, and then we can just say ball bar accuracy test PL3, and just ensure that we save it as an Excel file. We now have like a template we can use, and this is the report. So I've got all the parts in each of the tabs. So the file that we've got here I can import from a VxInspect report and just grab that Excel file and open it. And we can see here what the deviations are. So test 1, the distance was within 16 micron. Test 2, 22 microns for the volumetric accuracy. 13 micron for 32, and then 72. So all pass well within the 0.1 millimeter volumetric accuracy. And then for each of the spheres, we have 3 micron, 17, 4 micron, and 20, 26, and 11. So very good results. And you can see the max deviation for the volumetric accuracy was 72 microns on the right here. Sphere 1 was 45 microns, Sphere 2 was 28, well within what Peel and Careerform have specified on their brochures. So I really hope that you found this accuracy test of interest. If you're in New Zealand and you're interested in a PL3, please feel free to contact us.